Every predictive model starts with data, and we like to think of data as neutral, cold, hard facts about the world. But the truth is, data is not a mirror. It's a record of what we choose to observe, measure, and remember. And when it comes to policing, what gets measured isn't always what matters. Now, today on Curious Modeling, we're unpacking bias in the machine, how data, algorithms, and assumptions quietly shape what we call justice. Let's start with a simple definition. Algorithmic bias happens when a model produces systematically unfair or inaccurate outcomes for certain groups, not because the math is wrong, but because the data or assumptions behind it are. Bias isn't a bug in the code. It's a reflection of the world the code was trained on. If the data feeding your model reflects unequal policing, unequal reporting, or unequal access to justice, your predictions will too. And because the algorithm looks scientific, those inequalities can feel legitimate. That's what makes algorithmic bias so powerful and so dangerous. Bias in predictive policing tends to show up in three main forms: data bias, model bias, and outcome bias. First, on data bias. This is bias baked into the inputs, the data you train on. If one neighborhood gets more patrols, it generates more reports. That data then tells the algorithm, this area is risky, reinforcing the cycle. Next, to model bias. Even if your data were perfect, the model itself can introduce bias. For example, if you use arrest records as a proxy for crime, you're not predicting behavior. You're predicting enforcement. The choice of variables, the algorithm you pick, even the way you normalize data, all can tilt the results. Finally, there's bias in how results are used. This is called outcome bias. A model might predict accurately that Area A has higher reported crime, but if policymakers use that to justify heavier enforcement without addressing root causes, the model becomes self-fulfilling. Bias doesn't just distort analysis, it distorts action. Let's take a closer look at how bias gets hidden inside seemingly neutral variables. Arrest count often reflects patrol intensity, not actual crime. Calls for service depend on community trust. Some people call 911 often, others rarely. Neighborhood disorder might correlate with poverty, not criminality. Each of those features seems objective until you unpack the social meaning underneath. That's what makes bias insidious. It doesn't appear as prejudice, it appears as pattern recognition. Bias in policing data doesn't stay static. It compounds. When a model predicts risk in a certain area, police patrol it more heavily. More patrols mean more arrests and reports. That new data gets fed back into the next training cycle, confirming the model's accuracy. Over time, predictive policing stops being predictive at all. It just becomes a mirror of past decisions. And that's how an algorithm can take yesterday's inequity and scale it into tomorrow's standard operating procedure. So how do we see bias in the data? Data scientists use fairness metrics, mathematical tests for whether models treat groups equally. Two common ones are demographic parity, which checks if predictions are distributed evenly across groups, and equalized odds, which checks if accuracy is consistent for everyone. If your model falsely predicts high risk for one community more often than another, that's not noise. That's bias you can measure. The next step is to correct it. But that's easier said than done. Mitigating bias usually means doing two things at once: adjusting the data and then changing how the model learns. Analysts might reweight underrepresented groups, remove problematic features, or introduce fairness constraints directly into the algorithm. But the real challenge isn't technical, it's cultural. Bias correction isn't just about cleaner math. It's about acknowledging that fairness has to be defined, tested, and maintained over time. One of the best ways to fight bias is transparency, documenting models through algorithmic impact assessments or model cards that show data sources, assumptions, and limitations. Some cities now require these disclosures before deploying predictive systems. It's a small step, but it turns the model from a black box into a conversation. Because justice isn't just about accuracy, it's about explainability. Bias in the machine isn't just about technology, it's about the human choices that guide what we measure and value. Algorithms don't invent inequality, they inherit it. And if we're not careful, they preserve it perfectly. And the future of predictive policing depends on what we do next. Whether we use these tools to replicate the past or to rethink it. In our next episode, we'll look at how that rethinking is already happening, as cities experiment with predictive prevention, using data to target resources, not arrests.